Finally, we're going to find trig function values based off of these reference angles. This is where your special right triangles are really going to come into play. And I want to find the exact value of each trig function when we do this. So dealing with cosine of 240, we're first going to draw in our angle and then find our reference angle, just like what we did on example 3. So 240 degrees from my initial spot is going to land me in the third quadrant down here. That's going all the way around like so. And then to find and deal with trig functions, we're going to draw in right triangles. So if I draw in my specific right triangle, in this case, I want, again, to make it with the x-axis. That's where we'd always been making our right triangles. Our angle measure, we need to find this reference angle right in here. If this is all the way around 240 degrees, and I'm making it with the x-axis of 180, 240 minus 180 is going to get me a reference angle of 60 degrees. I can now use my right triangle, my 30, 60, 90 triangle, and instead of calling it x, x squared of 3, and 2x, we're going to say we're dealing with 1, square root of 3, and 2. We're going to plot those locations on here. You just need to be careful that you are dealing with some negatives. So across from 60, we know that that side length is square root of 3. Since we're going down, that's a negative square root of 3. Across from 30 is a value of 1. Since we went left from the origin, this is a negative 1. And the hypotenuse is always going to be a positive value because we're taking and using the Pythagorean theorem. So the hypotenuse is going to be 2. I'm dealing with cosine of 240, so I'm going to use my reference angle in here. Cosine is adjacent over hypotenuse. The adjacent to this angle measure is negative 1. So we're going to say the cosine of 240 is negative 1 over the hypotenuse, which is 2. And that would be your exact value. Let's scroll down. Let's try another one. Let's do the 135 one down here at the bottom. We'll do cosine of 135. Then we'll go back and we'll do some other ones as well. So cosine of 135, we're going to draw on our reference angle first. Draw on our location, then our reference angle. 135, that's going to be in our second quadrant. Going from there to there, that's 135 degrees. Draw in my right triangle. If I know this is, and here's my reference angle with my terminal side and my x-axis, I know that all the way around is 180. 180 minus 135 is going to get me 45 degrees. This time you're going to use your 45, 45, 90 triangle. Again, instead of using xx and x squared root of 2, we're going to say it's 1, 1, square root of 2. So across from this 45 over here, since we went up, that's a positive 1. This one down here, since I'm going left from the origin, that's a negative 1. And the hypotenuse, again, is always positive because we're using the Pythagorean theorem, gets us square root of 2. Cosine of 135. Remember, cosine is adjacent over hypotenuse, so we're going to use this 45-degree angle in here. Adjacent would be this negative 1 over the hypotenuse, which is the square root of 2. I don't want to leave it like that. I want to get the square root out of the denominator. So we're going to multiply square root of 2 over square root of 2. Gets us negative square root of 2 over 2 as our exact value. Let's do one that deals with radians out of this. Let's do cosecant of 5 pi over 6. Since we're dealing with reference angles, I would recommend just changing 5 pi over 6 to degrees. So again, to change 5 pi over 6 to degrees, we're going to multiply top and bottom by 180 over pi. We did that in the previous section. We're going to take 5/6 times 180. Get my calculator out here. Oops. That way you guys can see how we do this. I'm going to take 5/6 times 180. That gets me a degree of 150. So if we plot 150 degrees, that's the same thing as 5 pi over 6. Well, 180 is going to lie in the second quadrant. We'll make in our right triangle with the x-axis at the same time. There's 150. I need to get all the way to 180. My reference angle in here is 30 degrees. This again uses our 30, 60, 90 triangle. Across from 30 is 1. Since we're going up, that's a positive 1. Across from 60 is square root of 3. We went left of the origin, so that's a negative square root of 3. The hypotenuse is 2. Reminder, cosecant comes from sine, so if you need to, you can find sine first and then just flip it. Or just know that cosecant of, I'll call it 5 pi over 6, even though it's the same thing as 150, we know is hypotenuse over opposite. The hypotenuse we know is 2. The opposite in this case is across from 30, which is 1, or just a value of 2.